given by fx is equal to 4x plus 3, show that f is invertible, find the inverse of f. Do you know, we have already discussed this question in the introduction of invertible functions as example 4. So please refer your example 4. Now, next question is, consider f such that set of real numbers to the set 4 to infinity given by fx equal to x square plus 4. Show that it is invertible. And what do you need to show for invertible? That is 1, 1 on 2, and hence find f inverse. And of course, here R plus denotes the set of non-negative real numbers. This is R plus here, R plus, set of non-negative real numbers. Okay, so to prove it is invertible, let me first check that the given function is 1, 1. For that, let x1 and x2 are any two non-negative real numbers such that fx1 equal to fx2. And fx is defined as x square plus 4, so fx1 will be x1 square plus 4 and fx2 will be x2 square plus 4. 4 and 4 cancels, you get x1 square equal to x2 square or x1 equal to plus minus x2. So now x1 and x2 both being non-negative real numbers, x1 cannot be negative. If x2 is positive, x1 can't be negative of x2. So the only possibility is that x1 equal to x2 as x1 and x2 are positive numbers you can mention. So fx1 equal to fx2 implies x1 equal to x2. So you may safely conclude that f is a 1, 1 function. And now to check inverse, it is a 1, 1 function, and for on 2, to check on 2, given fx is equal to x square plus 4, x square plus 4, let it be equal to y, an element in the range of the function. Work out the value of x from here. X square is y minus 4 and x is equal to plus minus y minus 4. But remember, x being a non-negative real number, it cannot be negative. So finally, you get x is equal to under root y minus 4. And what is the interval for y? Y belongs to 4 to infinity. So minimum value of y is 4. So even if you take y equal to 4 here, what will be the value of x? It will be 4 minus 4 under the root 0. Yes, it will exist. So we can conclude that for each value of y, there is an x equal to under root y minus 4 such that fx equal to f of under root y minus 4. That is, what is the definition? X square plus 4. So it will be under root y minus 4 whole square plus 4. That is y minus 4 plus 4. 4 and 4 cancels, equal to y. So to each value of y, there is an x such that fx is equal to y. So it is on 2. So f is on 2. So as we have verified that f is 1, 1 and on 2, so f is invertible. And hence f inverse exists. And we have already worked out that fx is equal to y, and then there is a value of x which exists for corresponding to y is under the root y minus 4, for which fx is equal to y. So we can say f inverse y is under root y minus 4, that is inverse of y. Now this is a very good question. Consider f such that R plus, that is set of non-negative real numbers, to a set closed interval -5 to infinity. Of course, on an infinity side it is not closed. given by fx equal to 9x squared plus 6x minus 5, show that f is invertible. What do you want to prove for invertible? That is 1, 1 on 2, and hence find f inverse also. Let me tell you that in CBSE sample paper, from CBSE sample paper, it is a 6-mark question. The weightage for this particular sum is 6 marks. We need to prove 1, 1 on 2, and as soon as you prove on 2, obviously you get the value of x in terms of y. That will make it f inverse. That will be easier to find out by now. Okay, for 1, 1. First of all, let us check that the given function is 1, 1. For that, you take any two numbers, x1 and x2, as set of non-negative real numbers that is belong to R plus, such that fx1 equal to fx2. What is the definition of fx? 9x squared plus 6x minus 5. So it is 9x1 squared plus 6x1 minus 5 equal to 9x2 squared plus 6x2 minus 5. 5 and 5 cancels. And now you take all the terms on one side. You get 9 times x1 square minus x2 square plus 6 times x1 minus x2 equal to 0. Take x1 minus x2 common between these two terms. Why? Because the first term, this can be factorized as x1 minus x2 and into x1 plus x2. That I leave for you to try. So take x1 minus x2, I take directly common. You will left with 9 times x1 plus x2 and plus 6 equal to 0. Now remember, x1 and x2 are non-negative real numbers. So what about this number as such? Here x1 and x2 are non-negative, so x1 plus x2 will be non-negative. So 9 times this will be non-negative, means minimum it will be 0. So 0 plus 6 is definitely positive, and we can divide by a positive number. So if you cancel this factor from here, you simply left with x1 minus x2 equal to 0, or in other words, x1 equal to x2. So fx1 equal to fx2 imply that x1 equal to x2. So clearly the given function f is 1, 1. And now to check on 2, fx is defined as how much? 9x square plus 6x minus 5. Let me take it equal to y, an element in the range of the function. And from here, can you get the value of x in terms of y? So y equal to, try make it perfect square. It can be written as like 3x square plus 6x. So it is 2 into this 6x may be taken as 2 into 3x into 1. So you need plus 1 square here, and to compensate it minus 1 minus 5. If you know how to make a quadratic function as perfect square, you can do it. So it is like a square plus 2ab plus b square. So a plus b whole square, that is 3x plus 1 whole square minus 1 minus 5 minus 6. And now it will be easier to work out the value of x. So from here you get 3x plus 1 whole square equal to take minus 6 on the other side, y side, to make it y plus 6. And from here you get 3x plus 1 equal to under the root y plus 6, or 3x is equal to under root y plus 6 minus 1, or x is equal to under root y plus 6 minus 1 by 3. So finally you get this value of x, which corresponds to y from the range, such that fx is equal to y. Let us again verify that yes, fx is equal to y. So fx, that is f of under the root y plus 6, y plus 6 minus 1 by 3. Replace this value of x in fx. what is fx? Basically defined as 9x square plus 6x minus 5, which could be, rearranged as 3x square minus 6. So instead of replacing this value of x in the first definition, let us put it in 3x plus 1 whole square minus 6. It will be easier. So replacing x, that is 3 times, replace x by this, under root y plus 6 minus 1 by 3 and this thing whole square minus 6. Here the 3 and 3 cancels, so you get, here it was plus 1 also, sorry, 3x plus 1. So 3 this is x, 3x and plus 1 out, yes. So now 3 and 3 cancels, then you left with under root y plus 6 minus 1 plus 1 also, and this whole square minus 6. So this 1 and 1 will cancel, and when you square it, it will merely leave y plus 6 and minus 6 cancels, so you get y. So what do you confirm? That to each value of y, in the range of f, we can get a value of x equal to how much? We get x is equal to under root y plus 6 minus 1 divided by 3, such that fx is equal to y. So we can say that yes, f is onto. So finally f is 1, 1 and onto. So we conclude that f is an invertible function. And what is the value of x for which you get f inverse y? F inverse y is x. And what is that value of x? It is under the root y plus 6 minus 1 divided by 3. So finally, let me tell you that what is f inverse or f inverse y? It is under root y plus 6 minus 1 by 3. So it is invertible, and here is f inverse.